Alright, so the next step is to make this gear, this timing gear, fit on that pulley. So this needs to be bored out to 3 inches. This needs to be cut down to 3 inches. And then a bolt pattern needs to be put in so this thing can be attached to the pulley that goes back in the machine. So I'm getting the other pulley there. These two are the same. Set up for boring, and I'll bring you back when that's done. And now I've got the gear running. The face is running pretty true. I'm still showing the same high spot I was on the other lathe. I did flatten that out a little bit. I have it running within about 3/1000ths on the face. And now I have the bore running true too. It's really just about as close as you're going to get to zero. Picking up a little bit of noise with the indicator. But the interesting thing is I still am showing that cone-shaped bore. So as I move the indicator in, I get about a 15,000th taper. No matter where no matter what point of that bore I'm running in on. And I'm pretty surprised at that. I would think on a timing belt system like this they would really have to machine it a little more precise than that. I looked these gears up the other day on McMaster, and they sell for anywhere from it was like $70 to $200 a piece, depending on what size and so forth. But anyways, I aim to make it a lot better than that. Alright, I'm kind of holding everything in a very precarious position right here, but I have the bore, I have the pulley bored out, and the spec is 3 inches plus 0 minus 1.2 1.2 thousandths. So I'm getting about minus 2.5 to minus 5/10. I'm sorry, I meant 2.5 tenths, not 2.5 thousandths. Anyhow, that's about as good as I'm going to get it. I mean, this Fowler dial bore gauge, I doubt its ability to measure, down to 2/10 anyways. So we're going to call that good. The bore is nice and straight. It is not cone-shaped anymore. And I'm going to put a chamfer on the edges of the bore there, and go ahead and pull her off the lathe. Okay, I've finished machining down the old pulley, so now there's a hub that will fit the 3-inch ring that we've machined on the other pulley. We got a nice slip fit. I think I went 2 thou under on the old pulley, and I think it's like 5/10 over on the other gear. You hear that cast iron on cast iron there. Anyways, didn't get any footage of that. Now I'm setting up so. Woo, squeak. There's 3 1/4-20 bolts that hold the new pulley to the old pulley. So I scored a 4-inch circle, made my first punch mark, and then used dividers to get myself 3 exact holes. Yeah, that divider tip is not, there it is, not going in that hole. Hard to do this from back here. So anyways, those are my 3 spaced holes. Not quite sure how I'm going to hold it in the mill yet, but I'll get that set up and bring you back. So unfortunately my vise was too small for the pulley setup here, so I put a V-block on one side, a couple of 1, 2, 3 blocks on the bottom with some cant twist clamps and a strap up top, and that's my setup for drilling. Alright, I got the top pulley back in, the headstock of the lathe. This is the belt we're going to be using, but I need to find out exactly where that pulley lines up on this plate so that I can figure out where to mount the motor. I was just going to use a plumb bob to drop down through the spindle head and search for, I don't know, half an hour, 40 minutes for my stinking plumb bob last night. Can't find one. So, found some fittings and scrap. Let's see if we can make one. Alright, now I can get my 4 corners marked for exactly where that pulley needs to, where that belt needs to